Welcome to the Crazy Hat Chemist. So another video here on thermochemistry. So let's get moving. Bam! So today we are talking about enthalpy. Enthalpy is noted as delta H, and it's really, we're going to be calculating the change in enthalpy. That's the delta is for the change, the H is for the enthalpy. So let's get a definition of what enthalpy actually is to begin with. Enthalpy is the energy changes in a reaction are due to making and breaking chemical bonds. In addition, molecules have rotational, that is spinning around, vibrational, and translational energy, as well as nuclear energy. These combine to make up the total energy of the system. That is enthalpy. Enthalpy, or delta H, the change in enthalpy, is the internal energy of the system plus the product of the pressure and the volume, which is equivalent to the total heat content of the system. Okay, so we have been in previous calculations using this equation, and that is Q equals mc delta T. And the Q is the enthalpy term, it's the heat content that you've been calculating. Okay, all right, enthalpy is independent of path. Okay, therefore it is called a state function. So let me give you an example. If you're going to travel from your house to the grocery store, okay, you can walk there, or you can drive there, or you can go all the way around the world and get there. But all that matters is that the starting place is your house and the ending place is the grocery store. That is a state function. It is path independent. Okay, if the system liberates heat, gives off heat to its surroundings, or the temperature increases, i.e. it warms, then the enthalpy change is negative and it's called exothermic, like an exoskeleton. Okay, if the system requires heat, absorbs heat from its surroundings, or the temperature decreases, i.e. cools, then the enthalpy change, i.e. delta H, is positive and endothermic. Okay, like an endoskeleton, like us humans. Okay, now I did mention this on the last video and the last calculation, but I want you to make sure that the heat always flows from the hot object to the cold object spontaneously. It never occurs the other way around unless there's an input of energy. All right, so a little bit more about delta H and enthalpy. This is a graphic of the reaction progress along the x-axis. Along the y-axis is energy. Notice that on the left-hand side of this graphic, I have A plus B. Those are my two reactants. I get one product, and that is C. Notice that C is lower than A and B. Okay, this is characteristic of an exothermic reaction. This is heat liberating. The temperature goes up. That is, the product or products are lower in energy than the reactant or reactants. Conversely, this is an endothermic reaction of this graph. Again, on the y-axis is the energy. On the x-axis is the progression along the reaction. Notice that A and B on the endothermic reaction are very low in energy, the reactants, and the product, C, is higher in energy. Okay, that means that this is an endothermic reaction. Notice the two graphs and their characteristic graphic features of where the product is. Is it lower than the reactants, exothermic, or higher than the reactants, endothermic? Now, this is all really coming from a physics standpoint of view, and that is the system and the surroundings. Okay? So let me relate the enthalpy change from the system to the surroundings and vice versa. So from the system to the surroundings, heat is released by the system, and this is when the Q, that is the change in enthalpy, is less than 0. That is negative. Okay? This is work is done by the system. Now, the other side of this coin is heat is absorbed by the system from the surroundings. Okay, and this is when Q is greater than 0, that is positive. And this is work is done on the system. Okay, enthalpy change, very important, delta H. Okay, you must be an exothermic reaction because this room is getting hot. I am the Crazy Hat Chemist. I got a crazy hat. Give me a thumbs up if you like that video. Give me a thumbs up if you like the hat. Please subscribe to my YouTube channel and pass it on to anybody that needs more chemistry help. I got tons of chemistry videos out there for you. You need to find the one that worked for you. See you later. Bye for now.